Okay, so the bulk of this chapter, chapter 7, deals with factoring polynomials. There are other things. Obviously, we just did multiplying polynomials. We've talked about adding and subtracting polynomials. We've talked about naming polynomials. Eventually, we're going to solve the equations that involve polynomials. But for the bulk of it is going to be this idea of factoring. And factoring really you can think of as unmultiplying. All right, so think about when you learned how to factor, do prime factorization or whatever for back in 4th grade. We would take a number and we would basically break it down into its factors, all right, its prime number parts. So we could say that this was a 2 and a 6. That was prime, so we stopped there. 6 is 2 times 3. 2 is prime. 3 is prime. So this would be the prime factorization, was 2 squared, or 2 times 2 times 3, right? So factoring polynomials, again, is doing the same type of thing, is breaking a polynomial down into its prime factors, right? And there are 5 different types of factorization that we're going to learn, and the first is GCF factoring. So of those 5 types, the first is GCF. I'm going to keep saying them over and over and over again because I want you to learn them. The second type that we're going to learn is difference of squares. The third type is easy general trinomial. The fourth type is harder general trinomial. And the last kind is called grouping. All right, there are other types, but this is, if you can get these 5, you are well on your way to being a professional factorer. So let's just talk first. Let's go back again to what we just did about the multiplying polynomials. And I just want to look at, let's say, the first one, or maybe even an easier one. Let's say we had 6 times 3x minus 5. All right, and then we multiply that out, and we would get 18x minus 30. All right, but suppose somebody came along and wiped that out. All right, so all that was left was this. And we said, what was that before we multiplied through? What did we have before we got this? All right, so we would say, well, gosh, we multiplied something through. I know that I can't remember, but what was it? Well, let me look at these parts right here, actually the whole term in each of them. And we'll say, well, whatever it was the same thing that I multiplied through to each term. So what do these have in common? What numbers or variables do they have in common? So I would look and I would say, well, obviously 18 and 30 are not in common, but are there any factors of 18 and 30 that are in common? Well, yeah, they both have a factor of 6. That must be it. I must have multiplied through by a 6 because that's the only thing that they have in common. They don't have any variables in common. It's just that 6. So I'd say, I try to recreate it then. I say, okay, they must have multiplied through by a 6. All right, that was what was here first. So then I say, okay, well, what was it that was here then in each of these 2 terms? And I can say, well, I'm pretty sure I can deduce that that was a minus sign between them. But what was right here? So then I think, well, if I multiplied through by 6 and I got an 18, an 18x, then what must have been there is if I undo that and I take the 18x and I divide that 6 back out. Right, so then I say, well, 18 divided by 6, that's a 3. So it must have been a 3x that was there. Then I can do the same thing with a 30. Well, what was here before we got 30? Well, if I multiplied by something and I got a 30, if I multiplied by 6 and I got a 30, then to figure out what was there, I should undo that by dividing. 30 divided by 6 is 5. And so it must have been 3x minus 5. And then, lo and behold, that's what it was. All right, so this type of factoring where we have something where we're trying to remove some like some numerical value or some variable that is in there that was the same in both of them. When we try and factor that out, it's called GCF factoring. And hopefully you can figure out why. And it's because it is the greatest common factor of these terms right here that we're factoring out. So we're finding out what is the largest thing that they have in common, and we're going to unmultiply it. All right, so let's try one that we have not done before, and that is going to be another nice easy one here. So let's say we have 4x minus 6. So again, we're at this stage right here where we've already multiplied through. We've lost the original polynomial. We don't know what it is, but we're trying to figure out what this is or what this was before it. So I'm going to set this up, and I'm going to say there has to be some number or number and variable or just plain variable that was multiplied through, and then there will be something here minus, again because that's minus, and this right here. So let's look at these. Again, in terms of variables, they don't have anything in common, but let's look at the number parts and say, what factor do both 4 and 6 share? What is the greatest common factor between those two? So hopefully you're going to say 2 is the greatest common factor. So we say, okay, if we multiplied through by 2 and we got 4x, what was it that we multiplied through by? So again, on the side here, you can do this, or eventually you'll just be able to do it in your head. You'll say, what was there before we multiplied by 2? In other words, let's work backwards. 4x divided by 2 is going to give us what we need. When we cancel this, we're going to get a 2x. So this must have been a 2x. And then we'll do the same thing for the 6. We'll say, what was, if we multiplied through and we got a 6, and we multiplied through by 2, in order to figure out what we're multiplying by, we have to do 6 divided by 2. And we're going to get 3. All right, so this must have been what this polynomial was before we distributed. All right. So here's after we distributed, this is before we distributed. We can always go through and check to make sure we're correct by just distributing back in, and we should get this exact same thing. If you don't, if a sign is incorrect, a number, an exponent is incorrect, you've done something wrong. So let's just check. 2 times 2x gives us 4x, and 2 times negative 3 gives us negative 6, and that's exactly what we hoped for. All right, now let's take a look at this one. 10x squared minus 8x. So again, I'm going to say there was something, a binomial, that was multiplied by a monomial that gave us this, and I want to know what it looked like before we distributed that through. So again, we're going to have some monomial out here, and then we're going to have our two terms, and again, this just happens to be subtraction. They're not always going to be subtraction, so don't feel like that will always be minus. It's just because the last 3 examples all had minus signs in between. All right, so let's look at the number parts and see what is it that they share. What common factor do they share? All right, hopefully you said 2. Again, we're not talking multiples, so don't say 40 here. We want to know what divides into each because we're going to divide it back out. And then we look at the variable parts and we say that there's an x squared and an x. What is it that they have in common? Right? Again, think of this as an x times x, and this just as a plain old x. And we want to know, what do they have in common? Well, each of them have a single x. This has extra x's, but the thing that they have in common is 1x. Right? So we're going to say that the thing that we must have multiplied through by was 2x, because that is what each term has in common. All right, let's figure out what goes in here now. So if I distributed 2x in and I got 10x squared, in order to figure out what this is, I'm going to go backwards. I'm going to say, what's 10x squared divided by 2x? All right, I'm going to undo that multiplying through by 2x and figure out what it was that was there. Well, 10 divided by 2, this is our quotient rule now. So 10 divided by 2 is going to give us 5. And x squared divided by x to the first, remember with quotient rule, we subtract the exponents. So x squared divided by x to the first, we're going to subtract the exponents and get 1, and so we get x to the first, or just x. All right, which means this must have been a 5x that was here. All right, let's do it for the 8x. I'm saying I'm going to multiply 2 into something, and what happens after I do that is I get an 8x. So let's undo that. Let's take the 8x and divide by 2x to see what we must have multiplied by. All right, so 8 divided by 2 is 4. X divided by x, they just cancel out, so this is going to be 4. Let's check it. So 2x times 5x, and then minus 2x times 4. All right, 2 times 5 is 10. X times x is x squared. Minus, and then 2 times 4 is 8, and x isn't multiplied by anything, so it's just that. And that's exactly what we got. Okay, let's try another one. 5x squared w squared z plus 15 x to the 5th w to the 4th z to the 3rd. Right, this looks a little bit daunting because there's a lot of variables in here with a lot of exponents, but again, let's just take it one step at a time. I know that I multiplied by something, a monomial into a binomial, right? I'm going to put the plus in the center because these are going to match. Again, all 3 of these were negative, which is why all these were negative. This one's positive, so we've got a positive here. So we want to know what we multiplied into to get this. All right, so let's just go through one at a time. So we're going to look at the numerical coefficients and say what factors do 5, or what factor does 5 share with 15? Hopefully you say it's 5. All right, they both share a common factor of 5. Now let's go through with the x squareds. We're going to do it one at a time. There's no use comparing x squareds and w's because they don't have anything in common. So we're just going to compare these two. So again, this is an x times an x, and this is an x times x times x times x times x. What do they both have? Well, hopefully you say they both have x squared. 2 x's right there multiplied together. This guy has extras. He's got 3 extras, but they both have an x squared in common. So I'm going to say that. Then we'll do w squared and w to the 4th. So w squared is w times w. W to the 4th is w times w times w times w. What do they have in common? They both share w squared. This guy has some extras, but they both have a w squared, so I'm going to put a w squared here. And then let's do this. So this is just a plain old z, and this z cubed is z times z times z. What do they have in common? They both have a single z in common. Again, this guy has extras, but what they have in common is a z. Now don't think that always it's going to be the first one, because in each case, these exponents were the ones that were lower, and that's what we had in common. It's not always going to be that way. I was just lucky that that's the way it worked out. What is true, though, is notice in each case when we compared an x squared and an x to the 5th, the x squared, the lower one, was what they had in common. Same thing here, w squared and w to the 4th, it was the lower one, the w squared that they had in common. And same thing here, z to the 1st and z to the 3rd, it was the lower one that they had in common. So if I gave you really outrageously large exponents like z or x to the 27th and x to the 19th, you could say, oh, they're going to have the 19 in common, the x to the 19th. This one's going to have extras, but they'll both have 19 x's. So always look for the smaller exponent to show what it is they have in common. Okay, now let's figure out what's left. So again, what I'm looking for is what did I multiply the 5x squared w squared z by in order to get this right here, right? So what does this have to be? So I'm going to reverse it. I'm going to take this, the 5x squared w squared z, and divide it by this thing that I ended up multiplying by. So 5x squared w squared z to see what I got. All right, so let's go through here. 5 divided by 5, they cancel out. X squared divided by x squared, they are the same, so they cancel out. W squared divided by W squared, they cancel out. Z divided by Z, they cancel out. All right, I'm worried here that somebody's going to say, oh, that means it's a 0. It's not a 0. Remember, we've talked about this. Whenever you cancel everything out, there's still always an implied 1 in the numerator. And whenever you cancel everything out in the denominator, there's still an implied 1 in the denominator. And so this really ends up being 1. All right, so I ended up taking the whole thing out of this when I factored out that common factor. All right, let's do it with the 15, x to the 5th, w to the 4th, z squared. And I'm going to divide out by this thing that I must have multiplied through. So by 5x squared, w squared, z. All right, nope, sorry. This was actually a cubed, not a squared. Okay, so 15 divided by 5, they're going to cancel out, and it's going to leave us a 3. X to the 5th minus, divided by x squared. Remember, quotient rule, we subtract exponents, so this should leave an x to the 3rd. Here, w to the 4th divided by w squared. We use quotient rules, we subtract the exponents, so we get w squared. Same thing here, z to the 3rd divided by z. There's an implied 1 there. We subtract exponents, we get a z squared. So this was 3x cubed w squared z squared. And again, we could distribute this through and verify that we did that. Sadly, I am on red on my battery, so I am going to stop here, and I will let Sam help you verify that this is correct before he starts the next video. Okay, let's look at one more example of this type of GCF factoring before we pause and let you do some practice problems. So say we have 25x squared plus 30x minus 15. So notice that this one is different from the last ones in that it is a trinomial, whereas all the other ones were binomials. So we're going to go through and we're going to look to see if they have a numerical factor in common and if they have a variable factor in common. So let's do the variable factor first, because that one should be pretty easy. This one has an x squared. This one has an x. We're starting to feel encouraged, but then in the last one, there is no x. There's no variable at all. So I could not have multiplied something through to each of the three terms that contained a variable, because this one didn't get it, and we would have had to have given it to everything. So there is no variable term in common. So then let's look at the numerical parts here. I don't know why I'm doing it with 2 again. So let's see, we'll do it with 3. So I'm comparing 25, 30, and 15, and I'm saying to myself, was there a number that I could have multiplied through to all of them? In other words, is there a factor that all three of these, 25, 30, and 15, share that I would have multiplied through? And the answer should be 5. Right, so that must have been what I multiplied through. Now I need to find 3 things. So I'm going to have 3 blanks right here, one for each of the 3 terms that I must have multiplied through by. And I'm going to put a plus here and a minus here, because that's the signs that were in here. All right, so again, I'm saying, what did I multiply 5 by in this spot to get 25x squared? So again, we've done 3 of these examples. You might start to be able to do this without writing it out, but let's just do one more like this. So 25x squared, since I'm trying to figure this out, let me undo the multiplying. I multiplied by 5, so let me undo that. In other words, I'm going to take 25x squared and divide it by 5, this thing that I multiplied through. 25 divided by 5, that gives me 5. And then x squared doesn't have anything to divide by, so it just stays x squared. So I must have multiplied into a 5x squared in order to get 25x squared. All right, same thing here. I multiplied a 5 into something and I got 30x. So what did that have to be? So again, by this point, maybe you're thinking, oh, I can see what this is going to be. If I'm dividing that 5 back out, I must have multiplied by 6x in order to get 30x. But again, you could still keep taking that term and dividing it by this GCF, and you would get 6x. And then I'm going to do the same thing. What did I multiply? What was here that I multiplied by 5 that I got 15? And that would have to be 3. But again, you could always take the answer and divide by the thing that you multiplied by, and you'll get that 3. And again, I took care of the signs first, but you could also say I divided negative 15 by 5, and that would give me the negative 3. So you might want to wait until the end to do the signs, or you might want to do it right at the beginning. Okay, let's multiply through to confirm that that's true. Here I'm going to do 5 times 5x squared. Again, I'll do it down here. 5 times 5x squared plus 5 times 6x plus 5 times negative 3. That gives me 25x squared. That gives me 30x. And that gives me negative 15. And that's exactly what we had right here. Okay, so I'm going to ask you to pause. And I want you to do on page 103 in your workbook, numbers 1, 3, and 5. And then come back because I have one other type of GCF factoring problem for you to look at. Okay, so the last type of GCF factoring that we're going to look at today, there's an extension of this, but we'll wait until next week, is we're going to look at something like this. Now you might be saying, oh my gosh, this is too hard. I'm never going to get this. But it's the same idea. We multiplied this polynomial, or we multiplied a polynomial by something in order to get this, right? And we're wondering what was that I multiplied through by. So I'm going to do the same thing. I'm going to look at each term. Again, the term stops when there's an addition or subtraction sign outside the parentheses that separates one group from the next. So I'm going to look at this term, and I'm going to look at this term, and I'm going to say, what do they have in common? So I'm going to look at all the factors of each part of the term. So I see that this is made up of a 12 and a 6 plus x. The 12 is made up of smaller things like 2 2's and a 3, but that's a 12. And this is made up of w and a 6 plus x. Right, so I'm going to say, what do they have in common? Well, hopefully it's pretty obvious that they have a 6 plus x in common. All right, we might also want to compare these two factors of each term and say, do they have anything in common? Because maybe it's more than just this obvious 6 plus x. And I compare the 12 and the w, and I say no, because this is a number part and that's a variable part, so they can't have anything in common. So the common factor that they share, the greatest common factor they share, is this 6 plus x. Now that right there is weird, because all this time we've been doing this, we've been taking out monomials. And now what we're saying is, oh, they actually share a binomial, right? Again, you'll notice that because it's really obviously weird when you're looking at that. Right, and you can see that factor in common. So hopefully it's not going to be too weird to say that that's the common factor, because you can see there that that's what they share. All right, so now again, we're saying, what did I multiply this into to get this? Now I'm going to put the plus sign in here to get ready for that. And I'm going to say, okay, I multiplied 6 plus x times something, and I got 12 times 6 plus x. So I'm working backwards and I'm saying, okay, if I multiplied it in to get that, to figure out what that is, I'm going to take the answer, 12 times 6 plus x, and I'm going to divide that thing back out to find out what I must have divided this by, or multiplied it by. So now we can say, again, this is just weird. We have not yet gotten to this stage, but just trust me. This and this are identical, so we can cancel them out, just like we would have done with if this had been an x and an x. So these two are in common, so all that's left is a 12. All right, think about that for just a second. If I have this as my answer, and this was multiplied by something to get it, to figure out what that was, I divide that factor out. And they cancel out, and what's left is that 12. All right, let's do the same thing here. I'm multiplying 6 plus x times something, and I'm going to get this. So let's undo that multiplying by 6 plus w. 6 plus x. So I'm going to take the w times 6 plus x, and I'm going to unmultiply it by this. I'm going to divide by it. These cancel out, and all that's left is a w. All right, let's check it. So again, this is what I'm multiplying by. I'm going to take this and distribute it. I just want to make sure I get this back. So I'm not going to do that FOIL method that we've talked about because this doesn't look like FOIL. I'm just going to take and give this factor to the 12, and I'm going to give it to the w. So if I do that, I'm going to do 6 plus x times the 12. All right, that is 12 times 6 plus x because order doesn't matter, and that makes it look like this, plus 6 plus x times w. Again, I'm going to write that as w times 6 plus x. That's what we got. All right, so this would be the way we would factor it. Okay, let's look at the next one. 8r times z minus 3 plus 5 times z minus 3. Again, this looks weird because we've got these parentheses in here. Not in any of the other problems that we did earlier did we have that. So, but we're going to look through and we're going to say, do they have anything in common? All right, so I would say, again, it's pretty obvious that they share this z minus 3. But what we're looking for now in addition is there anything out front of that they have in common? The answer would be no. 8 and 5 don't share any common factors, and there's an r here, but nothing here. So the only thing they have in common is this z minus 3. So again, the question is, what did I multiply it into that I would have ended up with this as the answer? It's plus here. So I'll put the plus here. All right. So again, z plus 3 times what is going to give us 8r times z plus 3? So let's think backwards. We're going to say if I ended up with 8r times z minus 3 and I multiplied through by z minus 3, let's undo that multiplying through times z minus 3 by dividing through by z minus 3 and see what we get. These cancel, and I end up with just an 8r. All right, can you figure out what should be there? Again, what would we have to multiply? What would this have to be so that when I multiplied it by z minus 3, I get 5 times z minus 3? Hopefully you say 5, but let's verify that. So again, this is the answer. In order to figure out what this is, I'm going to divide by what I multiplied through by. So 5 times z minus 3 by what we multiplied through by. We cancel these out. It means that we must have been multiplying it by a 5 in order to get that. All right, let's just verify that. Multiply these out. So this is saying take z minus 3 times 8r. So I'm just going to write 8r times z minus 3. Again, I said z minus 3 times 8r, but multiplication is commutative, and that way it makes it look more like this. And then same thing, z minus 3 times 5. I'm going to write it as 5 times z minus 3. So it matches that. And that's it. So we would call this the factorization of this polynomial right here. Okay, let's try one more like this, and then I'm going to give you some harder some problems to try. Let's say we have 4w squared times 2r plus 9 minus 32w times 9 plus 2r. We've got a couple things going on here. So first, I would say, again, when you see these parentheses, your eye is just drawn to them. I don't know about you, but that's where mine goes right away. And I think, oh, I wonder if these are the same. So if you look at that, you might notice, oh, wait, this says 2r plus 9. This says 9 plus 2r. They're not identical. All right, but, well, what if I just, because addition is commutative, what if I just flip this one around so it looks like that? So I get 4w squared times 2r plus 9 minus 32w 2r plus 9. Good? Okay, so then we are looking to write this as something out here times something that we distributed 2. There's 2 terms here, so there's going to be 2 here. This is separated by a minus, so this is going to be separated by a minus. All right, so hopefully it's pretty clear that they both share a 2r plus 9. Again, here is our term divider right here. It's a subtraction sign, so this is our first term. This is our second term. These don't count. It splits this parentheses up into 2 terms, but not the polynomial into 2 terms. That's the one that does it. So we have 2 terms right here, and both of them share a 2r plus 9. Now let's look at these guys. All right, do they share anything in common? Hopefully you see that they both share a factor of 4. 4 goes into 4 once, and it goes into 32 8 times. So they both share a 4. And then they both share a w. Again, we look for the lowest exponent when the variables are the same, because this one will have a w, this one has a w plus an extra w. So what do they have in common? Just the one w. All right, now I'm going to multiply it into here, and I want to get this out from the first multiplication and this out from the second multiplication. So I'm going to say, well, this was the answer when I multiplied through by 4w times 2r plus 9. So let me unmultiply that. Let me divide by this to figure out what was here. So 4w times 2r plus 9. These cancel. The 4's cancel. And then we've just got w squared divided by w. Again, like bases, dividing. So quotient rule. So we subtract the exponents. We just end up with w here. Wow, I left way, way too much space here. This is just going to be a w. All right, so really I should have done this times this. And then we still put that minus sign. Okay, now let's do it by this one. So this was our answer. When we multiplied this times something, we got this. So now we're going to undo that by dividing 32w times 2r plus 9 over 4w times 2r plus 9. These will cancel. These will cancel. And 32 divided by 4 gives us 8. Right, so we would get an 8 right here. Right, so this whole thing, it's not just the 2r times plus 9. This whole thing times the w should give us that. This whole thing times the 8 should give us this. Let's just check that. So we've got 4w times 2r plus 9 times w minus 4w times 2r plus 9 times 8. Again, multiplication is commutative, so I can put these in any order. So I'm going to switch these two. So I've got 4w times 2r plus 9. And then w times w is w squared. That's exactly what we had right up here. All right, let's do it again with this. Minus, Now, again, multiplication is commutative, so I'm going to switch these two. And then once the 8 ends up here, I'm going to switch those two so that we end up with 4 times 8 times w times 2r plus 9. These two give me 32, w, 2r plus 9. And that's exactly what we had up here. So this right here is the factorization of this. All right, you're going to pause, and on page 103, you're going to do problems 9, 11, and 13.